Let us see a problem of solving Kirchhoff's current and voltage law. Okay. Now this is a two loop circuit. Okay. Here we are going to find the value of the branch current. So value of the branch current. What are the branches? 25 ohm branch is there, 10 ohm branch and 30 ohm branch. Elements are there. And the voltage sources, two voltage sources are there. One is 50 volt and another one is 100 volt. So the given circuit, we have to find the currents in the circuit. The first step is to draw this current direction. So you're going to draw the current direction. Okay, current direction. This is a current I1 current and this is I2 current. We have assumed it as both or in clockwise. Okay, now we are going to apply the Kirchhoff's current law. So what is the Kirchhoff's current law? Here it is the incoming current. I am going to assume it as I1 current here. Okay, and here outgoing current, here it is I2 current, and here this is current in this 10 ohm resistance is I1 minus I2 current. Okay, now the next step, first step, we have written the A, we have allotted the node points. So this is a node point, A node, B node, C node, D, E, F. So we have now first allotted the naming of the nodes, and the second step is the loop. So first we are going to take a separate loop. Okay, so what is this loop? There is a, here it is A and this point is B, this point is E, and this point is F. This node we have selected, and we are going to apply the KVL, Kirchhoff's voltage law. Okay, so here the entry point is assumed as positive, negative. Here resistance positive, negative, and this is the current direction we have assumed. Okay, and so the current entering here, so the current is entering this way. Okay, from this point the current is entering. The loop also named as A, B, E, F, A. This is the path traveled by the loop. This is a loop path and this is the current direction. So both the loop path, here it is positive to negative. So it is a drop, same direction, positive. This is loop direction, the current direction, both are same. So here it is, we are writing it as minus 25 I1. Current assumed here is I1, and here it next it enters into this resistance, 10 ohm resistance, positive, negative. When it is entering into the positive means it is minus, so it is a potential drop. Minus means potential drop, minus 10 into I1, and then it enters into the voltage. Okay, battery. Minus means positive. Here it is plus 50. It is a potential rise. So minus to plus voltage means it is potential rise is equal to 0. So simplifying it, we are getting the equation as 35 I1 minus 10 I2 is equal to 50. So next, coming to the loop, step 3. Loop, we have taken the loop as B, C, D and E. So this is the loop we have taken, second loop, and named it as I2. Okay, and another thing here I forgot to tell, here it is we have taken it as plus to minus. Here only one current is there, I1 current is there, but here in across the 10 ohm resistor we have two currents acting. If you see in this circuit, what happens is that this resistor uh, is between I1 loop, this loop, first loop, and this is the second loop. So both the current will be acting upon this 10 ohm. Okay, is it clear? So now it is, when we are considering this circuit, what happens is that I1 current is flowing here. So plus to minus means it is potential drop. Okay, while, so here we have written it as minus 10 into I1. When we are taking it as a current in this I2 if I am taking, I have written in this loop the current entry will be, this is the current entering will be plus to minus, again plus to minus, here it is plus to minus. So here it is plus to minus, here it act as a potential rise. Okay, it is potential rise. Okay, so here we are written it as plus 10 into I2 plus 50 is equal to 0 in the equation. When considering the step 3 in the loop, what is the loop? B, C, D and E, taking this loop, I am applying the Kirchhoff's voltage law. So according to the Kirchhoff's voltage law, sum of the potential drop and rise is equal to 0. Here I mean the this is the starting end of the loop, okay, or the mesh. Through this the current is traveling like this and closing. This is, so plus to minus means potential drop. Okay, plus to minus, it is a potential drop. The current path will be here. This is a current path and this is a loop path, and current direction both are in same. Plus to minus potential drop, so minus 30 I2. Next is enters into plus minus. Plus minus means here it is plus to minus means potential drop. Okay, here it is minus 100. Okay, again it enters, this resistance is being between I1 and I2, both the current will be there in this resistance. Okay, so what happens is that here the I2 current enters to positive and leaves through negative. This is the loop direction. Okay, so it is minus, here it is minus 10 into I2. When I am considering the I1 here it is, so I1, the entry point will be here, this side will be plus minus. Okay, so what happens is that here it is called as the, what happens, opposite direction. The here if you see the loop equation will be like this, loop direction will be like this, and the current direction is opposite. So here we will be writing it as positive. Okay, plus 10 I1 plus 10 I1 is equal to 0. So after simplifying I am getting this equation. Okay, solving this, both the equation number 1 and equation number 2, we are getting it as I1 is equal to 0.769, I2 is equal to minus 2.307. Okay, and the center limb, what is the current here? It is nothing. Here the current entering is I1 current, and here the current is I2 current, and here the current will be I1 minus I2 current. So we have to find this current, and this is the current in this branch. The negative sign here, where I2 current is equal to minus, indicates the assumed current direction is opposite. So this current direction is not clockwise, it is actually anti-clockwise direction.